Hello everyone and welcome back to Let's Learn. Today we are diving headfirst into a topic that sounds like it's straight out of a science fiction movie, but is very much a reality in the making. We're talking about one of the most powerful and mind-bending technologies of our time, quantum computing. So, what exactly is quantum computing? Let's break it down. Think about the computer or phone you're watching this on right now. It operates on a simple binary system. Everything it does, from displaying this video to sending a message, is broken down into a series of bits. A bit is like a light switch. It can either be on or off, representing a 1 or a 0. This has served us incredibly well for decades, powering the digital revolution. But quantum computing plays by a completely different set of rules. Instead of bits, it uses something called qubits. And this is where things get fascinating. A qubit isn't just a 0 or a 1. Thanks to a bizarre but wonderful principle of quantum mechanics called superposition, a qubit can be a 0, a 1, or, get this, both at the same time. Imagine a spinning coin. While it's in the air, it's not definitively heads or tails. It's a mix of both possibilities. It's only when it lands that it settles into one state. A qubit is like that spinning coin. It exists in a superposition of states until it's measured. This ability to hold multiple values simultaneously is what gives quantum computers their incredible power. While a classical computer with 8 bits can only represent one of 256 possible combinations at any given moment, a quantum computer with just 8 qubits can represent all 256 combinations at the same time. As you add more qubits, this power grows exponentially. A 300-qubit quantum computer could, in theory, represent more states than there are atoms in the observable universe. Mind-blowing, right? But superposition is only half of the magic trick. The other key concept is something Einstein famously called spooky action at a distance. It's officially known as entanglement. When 2 qubits become entangled, they become intrinsically linked. Their fates are tied together, no matter how far apart they are. If you measure the state of one qubit, you instantly know the state of the other, even if it's on the other side of the galaxy. It's like having 2 of those spinning coins, but they're magically connected. The moment one lands on heads, you know the other has landed on tails, without even looking at it. This interconnectedness allows quantum computers to perform complex calculations with a level of coordination that classical computers can only dream of. So, we have these super-powered computers that can explore countless possibilities at once. What are they actually good for? Well, their potential is staggering and set to revolutionize entire industries. Let's start with medicine and materials science. Creating a new drug or a new material often involves understanding how molecules interact. Simulating these interactions is incredibly complex, even for today's most powerful supercomputers, because molecules themselves behave according to quantum rules. A classical computer struggles to accurately model this, but a quantum computer, it speaks the same language as the molecules. It could simulate them perfectly, allowing scientists to design revolutionary new drugs, tailored to an individual's DNA, or create new materials with incredible properties, like room temperature superconductors that could lead to lossless energy transmission. Then there's the world of finance and optimization. Think about complex problems like optimizing global shipping routes, managing massive investment portfolios, or designing more efficient airline schedules. These are optimization problems with a mind-boggling number of variables. Quantum computers could sift through all the possibilities simultaneously to find the absolute best solution in a fraction of the time it would take a classical computer. This could save industries billions of dollars and dramatically reduce our carbon footprint. And of course, we have to talk about artificial intelligence. Machine learning models, especially deep learning, require immense computational power to train. Quantum computing could accelerate this process exponentially, leading to more powerful and sophisticated AI. Imagine AI that can design complex engineering projects, discover new scientific principles, or even compose music that rivals the classics, all at a speed we can't currently comprehend. Now, let's address the elephant in the room: cryptography. Much of our modern digital security, from your online banking to secure government communications, relies on encryption methods that are based on the difficulty of factoring large numbers. For a classical computer, this is an incredibly time-consuming task. For a powerful quantum computer running an algorithm like Shor's algorithm, it would be trivial. This means that, in theory, a quantum computer could break most of the encryption we use today. It's a scary thought, but the good news is that the same principles of quantum mechanics can be used to create new forms of quantum proof, encryption. Quantum key distribution, for example, uses the properties of entangled particles to create unbreakable communication channels. If anyone tries to eavesdrop, the very act of observing the particles changes them, immediately alerting the sender and receiver. So, while quantum computing poses a threat, it also provides the solution. So, if this technology is so amazing, why don't we all have quantum laptops? Well, building and operating a quantum computer is one of the greatest engineering challenges of our time. Qubits are incredibly fragile. The slightest disturbance from the outside world, a tiny change in temperature, a stray magnetic field, or even a vibration, can cause them to lose their quantum state in a process called decoherence. It's like that spinning coin being knocked off its course before it can land. To prevent this, quantum computers have to be kept in highly controlled environments, often cooled to temperatures colder than deep space, and shielded from any external interference. They look less like a desktop PC and more like a giant futuristic chandelier of wires and cryogenics. Scientists and engineers all over the world are in a race to overcome these hurdles. They're experimenting with different ways to build qubits, using everything from superconducting circuits to trapped ions and photons. The goal is to create systems that are not only powerful, but also stable and scalable, with robust error correction to handle the inevitable decoherence. We are still in the very early days. Much like the 1950s for classical computers, the machines are large, expensive, and require teams of experts to operate. But progress is happening at an astonishing pace. So, what does this all mean for us? While you won't be buying a quantum gaming rig anytime soon, the impact of this technology will begin to trickle down. In the near future, we'll likely access quantum computers through the cloud, using them to solve specific, highly complex problems that are impossible for our current machines. They won't replace your laptop for checking emails or watching videos, but they will be the engine behind the next wave of scientific discovery and technological innovation. They will work in tandem with classical computers, each tackling the tasks they're best suited for. In essence, quantum computing is not just an upgrade. It's a completely new paradigm. It's a shift from processing information to harnessing the fundamental laws of the universe itself to compute. It represents a future where we can solve problems that are currently unsolvable, understand the universe in ways we've never imagined, and unlock a new era of progress for humanity. The journey is just beginning, but the potential is truly infinite. Thank you so much for joining me on this deep dive into the quantum realm. I hope you found it as exciting as I do. If you enjoyed this journey into the future of technology, please hit that like button. It really helps the channel grow. And if you haven't already, Make sure to subscribe to Let's Learn and ring that notification bell so you don't miss our next adventure. Share this video with anyone who loves science and is curious about what's next. Thanks for watching, and as always, stay curious.